Alrighty, so today we're looking at exercise 3E, which is called solving literal equations. So, a literal equation is an equation whose solution will be expressed in terms of another variable rather than a number. Literal equations have two or more unknown variables or values, okay? So yeah, you're going to have obviously more than one variable, so it's not just going to be x, you'll have x and y or something like that. It'll be expressed in terms of another variable. So, like for example, this equation, okay, so you've got x plus 2y equals 6, so you've got two variables, more than one. Then its solution, so if it's asking you to express it in terms of the x variable, that kind of means it wants x by itself, so x on its own side, so x equals something. So with a literal equation, you're not going to get an actual number solution, but you're going to get this one, x equals. So the difference from the last equation is that it's subtracted 2y. So still doing those opposites. So instead of plussing, you subtract to get rid of it from that side. But whatever you do to one side, you've got to do to the other side. So you would have to subtract 2y on that side. Okay, so that's how they get the x by itself here. And then you've got 6 minus 2y, which is here. Okay, so we've now expressed this equation in terms of x because we have the x by itself. The process of rearranging an equation to be expressed in terms of another variable can also be called transposing. So transposing is just another word for like changing. Okay, changing the equation around so that you get whatever you want on the side by itself. So for an example, we've got 2a minus 4b equals 8, and we want to find an expression for a. So that means we want to get a by itself, okay? So looking here, we write the original equation. Okay, see how this a, we want to get that a by itself, so we need to undo the minus 4b and the 2. So using our solving skills, we can get rid of the negative 4b here by plussing 4b. Okay, that'll undo it so that that goes away. Obviously, if we've plussed 4b on that side, we have to do it to the other side, which is why we get that. Okay, so we end up with this line, 2a equals 8 plus 4b. All right, we still don't have the a by itself. We want to make a the subject, or a on its own. So we need to get rid of this 2. At the moment it says 2 times a, so we need to go divide by 2. Okay, the opposite of times is divide. And whatever you do to one side, you have to do to the other side. Divide that whole side by 2. Okay, so 2a divided by 2, so that goes away. So we've got a by itself, which is what we want, and we just need to simplify the other side. So 8 divided by 2 is 4, and 4b divided by 2 is 2b. Okay, so we have transposed this equation to make a the subject down here. Okay, so there's a few different synonyms here, so it's either transpose or express in terms of whatever variable, or make a or x the subject. There are some CAS instructions here. So in your calculator, you will go to menu algebra solve. And so it's the same thing as what you've been doing before, but obviously if you're trying to find a variable, okay, so you're trying to find a, then it'll give you the equation that you need. Okay. And another example, sometimes you'll get expressions that have absolutely no numbers, but you can still transpose them to get whatever you want as the subject. So for example, we have this equation, y equals mx plus c. Hopefully some of you remember that as the equation of a straight line. And for example, we might want to transpose the equation to find an expression for m. What that means is we need to rearrange or change this equation so that we have it with m as the subject, or m by itself on its own side of the equal sign. Okay, so by hand, this is how you can do it. Okay, so you're going to get m by itself, so you need to get rid of this c, and then you need to get rid of the x, okay, by doing the same to the other side, and doing those inverse operations. So you can follow the steps along here, and you'll finally get m equals this. So it's very handy for when you know certain values for these variables. And if you're trying to find, so in this example, you might know an x and a y point on your line, and you might know the y-intercept. So to find the gradient, you can actually substitute all those values in to this equation to find m, to find that gradient. So that's just another way of finding a gradient. And obviously the other way, you can use your CAS, like you've been using it already. So you can now go on with chapter 3E.